But conventional loudspeaker design hasn't changed in nearly 100 years, and to create an effective acoustic weapon, you need something a little more sophisticated. Behind the mirrored windows of this ordinary-looking San Diego office block, one successful inventor has achieved what was previously thought to be impossible. He's designed the world's first truly directional combat loudspeaker.
When I was a kid, I think I was in high school before I saw my first TV set. So what there was sound.
Woody Norris has spent more than 30 years building and patenting hundreds of hugely successful ideas.
I thought up my first invention kind of as a joke, and then after coming up with the idea, I thought, well, this maybe isn't a joke. Maybe this will work.
Woody's breakthrough was to realize that if sound waves could be focused in the same way as rays of light, it would open up a whole new world of possibilities.
What if you turn on a light bulb and the light just went everywhere, like the original Edison light bulb did? What good is that? Well, it lights you up in the dark, but you wouldn't have things like movies. You got to project it, focus it, shine it in a direction. That's controlling and projecting light. I thought, well, geez, we got to be able to do that with sound.
Now, how is your device different from a regular loudspeaker?
Well, I just happen to have a conventional loudspeaker right here. Probably about the size you see in a woofer in your home audio. Okay. I got a 9-volt battery. Just going to put it across the terminals. Watch what happens to the cone. If I do this, doesn't matter which way I turn,
I can still hear it.
You hear the sound. Now, hypersonic sound is totally different. This is truly the first difference in the way we make sound since the invention of the loudspeaker nearly 80 years ago. It's like a spotlight. In fact, it's almost like a laser beam.
A conventional loudspeaker generates audio waves in every direction, which spread out as they travel like ripples on a pond. The volume heard by the listener drops off quickly the further away he is. Woody's design is different. It uses highly directional ultrasound at much higher frequencies to carry the regular audio. These travel in a focused beam so they don't spread out and they don't get quieter even over long distances. On the battlefield, this ability to focus sound waves can be used to send clear audible messages over incredible distances. But for practical use in a real-life combat situation, obviously you need something a little bigger. Enter the Long-Range Acoustic Device, LRAD for short.
Compared to what we saw inside, this little guy is over 10,000 times louder. Now with this device, I can put out 155 decibels and stand where you are, or back here where I am, and hear it, but be comfortable in the level and not worry about suffering ear damage. Go out about 20, 30 feet and walk yourself across in front of it, and you'll notice about a 40 to 50 decibel increase in the output level from being off to the side as to being in the beam.
It's not so intense right here, but I can definitely hear it. And now as I start to walk in front of it, exponentially, with each step I take, it gets louder and louder. I'm having to compete with the sound. And now I'm standing right in front. I mean, it is very loud right here.
Now remember, that's the minimum level.
That's the minimum level. And
right here, evidence.
Okay, could you increase it just a little bit? That is very, very, very loud. Okay? It's like getting punched in the eardrum. Really,
right.
it's like a laser pinpoint toward my eardrum.
The reaction we've had from test groups that we've used with this product is that it's like putting on handcuffs.
All right.
You drop what you've got and you cup your ears.
A chilling example of how the LRAD could have saved lives took place on October 12th in the year 2000. A small boat loaded with explosives approached the battleship USS Cole while it was refueling in the Middle East. The guards on the deck were prevented from opening fire by the ship's rules of engagement.
When that happened, there were 50 sailors on deck with M16 rifles. Dangerous,
absolutely,
of course, but they didn't want to shoot civilians.
If the Cole had opened fire and the boat's passengers had turned out to be innocent civilians, it would have caused a major international incident. So instead, the sailors on board were forced to simply stand by and watch it approach. 17 U.S. sailors were killed in the attack. 39 more were injured, and the damage to the coal was estimated at around $1 billion.
The fundamental conclusion is that we must view terrorists as a relentless enemy, and they will continue to tenaciously look for exposed seams in our force protection armor.
And so the difference between doing nothing and killing people is the gap that's filled by this product.
And with this product, this is a less than lethal or non-lethal product?
Yeah, it falls in that area, that gray area, well below being lethal, never would kill or injure anybody permanently. But it has a volume control that allows you to get sufficient output that you can cause people great severe discomfort.
Right.
Because our ears are a sensitive instrument. And when I raise the level of speech up to a certain threshold, it becomes physically painful.
You're in a Navy vessel exclusion zone. Reverse course immediately or I will fire upon you.
If they continue to approach, you get a little more stern in your commands. If they get within the 500-yard perimeter, you know they are not there by accident. And so then you can flip it into high gear. And the output increases by about 5,000 times per setting of the volume control. And so what I do then is give them some discomfort and go from a voice to a whole variety of tones. The LRAD right now is deployed in Turkey, Afghanistan, of course, Iraq. Most recent count is we have over 300 of these in Iraq. And so, again, it's like having bullets where you have a volume control.